The biomechanical topic that I would like to discuss is the stress-strain curve and how an implied force can affect the original resting length of the material that the force or load is imposing. The definition of the stress-strain curve is a graph that measures the deformation or the change in shape of a material as a result to the load applied to the material. So to further explain this concept more clearly, this is a curve that has two components to it, and they are stress and strain. So stress is the force that is applied to the material, and strain is the deformation or change in the length of the material that is caused by the stress or applied force. So this curve illustrates how much force a material can handle before the material is changed without the ability to return to its original length. The curve also can describe the stiffness or compliance of a material. So to further explain, the stiffness of a material is represented by the steepness of the stress-strain slope. If the material is more stiff, and resistance to lengthening, then the slope will be more steep than if the material is said to be compliant. And a compliant material is less resistant to change and is able to change its original length more easily if it is said to be stiff. And for example, bone is more stiff than a tendon or muscle. A bone cannot change its length as easily as a muscle can be stretched and then recoils back to its original length. So there are two regions of the stress-strain curve, and the first region is the elastic region, and this is when the material can return to its original length after the load or stress is removed. And the next region is the plastic region, and this is where permanent damage is made to the material. And when the load and stress is removed, the material will not return to its original length. And so the yield point is the point where the elastic region changes to the plastic region, and this point is where the material will no longer return to its original length. And then the failure point is the point where the plastic region, where the load or stress continues to increase, and finally the material will break or fail. So some examples are, in most running shoes, there is a maximal mileage usage to determine when you should replace your shoes. So most running shoes are said to last between 300 and 500 miles before the material begins to change or fail. So within that time period, you should get new running shoes. So as the shoes materials begin to change within that time frame, the material cannot return to its original form after this threshold because of the yield point has been reached. So when you wear the shoes past this recommended time period or mileage, this actually can lead to injuries for the individual because the supportive material does not return to its original length and is not as supportive as it once was. Another example of how stress-strain curve can affect material is within the human body. Human ligaments, tendons, muscle, and bone also have a certain amount of stress before damage and injury occurs. For example, if an athlete injures their hamstring during a sprint, the load that was applied was too great for the muscle fibers to recoil and return to normal length. The muscle was stretched further than it was capable of going and was damaged because of that cause, and this damage is known as a strain, and the muscle fibers have been torn. And another example is an Achilles tendon rupture, and this is complete failure of the tendon due to the force applied, and this makes the tendon lengthen where the tendon cannot return to normal. And this is an example of how a material reaches the failure point, because an implied force increases to that point and then it fails, which then it breaks completely and is damaged and will need surgical repair.